The first action to undertake is to create a simple Maven project and skip archetype selection. It's recommended to be accustomed to creating formal group ID and artifact ID. For example, I will use a group ID related to this platform. For artifact ID, which is the project name, it should be related to the workshop itself. The next action is to add the JUnit dependency. We will use the latest published version of JUnit 5 from Maven Central. Let's create a main code class, entitled myMath, for example. It should be placed in a package that uses the group ID. Let's define two methods, factorial and Fibonacci. Initially, they will throw unsupported operation exception. These methods will be implemented after writing fully operational test code, contextualizing TDD. It's time to use JUnit tools. Right-click on myMath class, click on JUnit tools, then click on Generate Test Class. Uncheck Test Suites, and check both methods factorial and Fibonacci to be generated. Click on Finish. Indeed, in Test Source folder, JUnit tools created the test class and its respective package and minimalistic test methods. Let's clean the test code. The generated variable result should be renamed to actual, to be aligned with this course material. A variable called expected will be used with assertions. Let's implement general tests from n equals 1, all the way to n equals 4. Be careful, this test method is only for the aforementioned optimistic mindset. Let's implement pessimistic test cases. In the first pessimistic scenario, we need to handle a negative value as an input. It must be considered as an illegal argument. With JUnit, we will expect from factorial method to throw an illegal argument exception when n is negative. An assertion will be added to confirm the message of the thrown exception is the one expected by the test case. In the second pessimistic test case, the maximum capacity of an integer value must be controlled. When a value is greater than the integer's maximum value, this value becomes negative. Hence, factorial method must not return a corrupt value. That's why an illegal state exception must be thrown. Likewise, this test case will be corroborated by the exception message assertion. Let's run this test class with JUnit. Now, with TDD, the implementation goals are defined. Let's implement the factorial method, and let's consider Fibonacci method an assignment for you. Before passing to main code, let's ignore Fibonacci test method, as it is part of the assignment, and focus on factorial test cases. To implement factorial method, we will start with the general case, which is related to the optimistic mindset. Let's execute the tests. The factorial test method is successful. It is noticeable the illegal state test case is taking forever to execute. We will have to take this aspect into account. Let's address the illegal argument test, where the argument, n, must be checked, and an illegal argument exception must be thrown when it is negative. To solve the latency problem, we will check if result variable is negative or equals 0 at every iteration. Inside loop. We don't have to wait for the loop to finish before checking the value of result variable. Running tests with JUnit, all test cases ran successfully. We have successfully written both main code and test code.